Today we are really excited because we are launching our new material, the filament HT-PLA, which stands for high temperature. My name is Alessio and welcome to Spectrum Filaments. Like I said, I'm really excited to show you this new filament, HT-PLA, which stands for high temperature, of course. We have some tests to do, so let's get right into the video. We're going to test this amazing filament in a few ways. First of all, we're going to test the filament in a stress environment, such as an oven with other filaments to compare the melting threshold. And then we're going to test the filament in a natural environment, such as a household appliance, as an air dryer, for example. This is the tip of an air dryer that I printed with HT-PLA. And this was the result with the normal PLA. And then we're going to test the filament for bed adhesion and warping with this simple print. For this test, we're going to use the standard PEI sheet build plate compared to the cool plate super tack, with different bed temperatures and brim or not brim. And last but not least, we're going to test the filament to see how brittle it is and how resistant the filament is. So get comfortable, get a snack, relax, and enjoy this video. And here we are in the oven with our 5 filaments: PLA, PETG, ABS, PC, and of course HT-PLA. At 50 degrees Celsius we have PLA going down, followed by PETG at 75 degrees, and then ABS at 95 degrees, followed by PC at a whopping 140 degrees. But still standing and holding its shape, we have our new HT-PLA. And for the hairdryer test, we can see the tip of the hairdryer going down around 60, 65, 70 degrees Celsius. It was a little bit difficult to catch the temperature correctly, but we got it. And you can see it's really soft, almost melted, and yeah, the shape is completely gone. And for the HT-PLA, again, around 75 degrees, 70 degrees, again, was really difficult to catch the temperature like that, but we got it perfectly. Still preserving its shape, no deformation, nothing whatsoever, same hardness, same shape as the beginning. We can compare the two of them together. As you can see, one is completely gone, the shape is gone, and the other one is still perfect. And still very usable for its purpose. And now we're loading our The Filament HT-PLA in the AMS, ready for the warping and bed adhesion test. The bed temperature is set to 45 degrees Celsius and no brim. Even this one, it looks like it's gonna hold up, but after a while you will see that the front is warping. We can stop the print and inspect it. We have a really bad warping at the front and just a tiny bit in the back. Next up, we have still the same PEI sheet, bed temperature at 45 degrees Celsius, and this time we're using a brim. Fingers crossed this time seems okay. Even halfway through, it seems like there is no warping. But again, at the front we can still see a little bit of warping. Inspecting the print, we can see the front warping as well as a little bit at the corner in the back. But this is the actual real test. Clean build plate using IPA or dish soap. Some glue will be mentioned later, and 50 degrees Celsius on the textured PEI sheet build plate, and obviously a brim. This is the absolute win condition for our HT-PLA. And finally, for the last test, we are using the Bambu Lab Cool Super Tack build plate with the bed temperature set to 35 degrees Celsius and no brim. We are halfway through the print and there is still no warping, so this is a really good sign. I decided to let this one finish completely and see the result. And for the next test, I printed two little bars with the same settings, one of course in normal PLA and the other one in HT-PLA. And I was trying to break them and see which one was gonna break first. And the crack was from the actual PLA, the orange one. In fact, it's super brittle and it cracks badly. And then bending them more and more, we can see the normal PLA, it's completely destroyed. All the layers came apart and there is nothing to use here. Well, and the noise says it all. But the HT-PLA, it's still pretty much intact, and even though it's a little bit broken, it's still soft but also stronger than the normal PLA. In fact, it took me a little bit to break it. And here they are side by side. And there you have it, our new filament, the Filament HT-PLA. The tests were really successful, especially the one compared to the other materials. We saw the cascade from PLA, PETG, ABS, PC, and finally we still have the HT-PLA standing right there. We have maybe just a little bit of melting thing, but that's due to the infill of the actual print. And after that we saw the warping issue that we have with the standard PEI sheet with no brim, with brim, down to 35 degrees with the Bambu Lab Cool Super Tack build plate. So what we learned is that if we want no warping whatsoever, or maybe just a slightly on the tip because this is a really extreme print, we need to use the Bambu Lab Cool Super Tack build plate with no brim, and this was the result, as you saw in the clips before. Obviously you can use any build plate such as the normal PEI sheet from Bambu Lab or any other, but make sure that you check the temperature and use a brim. And forgot to mention the hairdryer test, which was really successful. We got the HT-PLA test right here, which is still perfect. And it was up to 70 degrees, I believe. And this one was normal PLA, still spectrum filaments, and it melted completely. So really successful test on an actual huge a practical print that you can use in your household. And this last test that I did to see how strong and brittle the filament was actually me. When I tested the filament, I realized that it was pretty soft. And I have to say, soft doesn't mean weak. In fact, this is way stronger than normal PLA. And here is the result. And we are at the end of the video, but before I leave you, I'm gonna give you some specs and details about the filament. And here they are. Heat stability up to 150 degrees Celsius. The Filament HT-PLA is a next-generation advanced PLA filament that sets a completely new standard among 3D printing materials. It's your go-to solution for demanding applications. Thanks to its unique formulation, HT-PLA offers impressive thermal stability of up to 150 degrees Celsius, combined with a semi-matte finish that gives your prints an elegant and refined appearance. What's more, enables the creation of objects that are fully dishwasher safe. Is a reliable choice for a wide range of applications. Eco-friendly, high performance, reliable, maintains its shape at high temperatures up to 150 degrees Celsius, resisting sagging or deformations under its own weight. Thermal resistance depends on the wall thickness of the printed part, but most importantly, it is achieved immediately after printing, with no need for annealing or additional post-processing. This makes the filament ideal for use cases where other filaments fall short. Perfect for creating durable end-use parts, device housings, brackets, mounting components, organizational accessories, and everyday items that demand high thermal and mechanical performance. While designed for strength and functionality, is also fully compostable and made from renewable resources, making it a conscious and environmentally friendly choice, when standard PLA just isn't enough. The Filament HT-PLA is an exceptional filament that clearly outperforms traditional PLA in mechanical properties. It is over twice as stiff, more resistant to tensile stress, and offers 3 times the impact resistance. This powerful combination of rigidity and toughness makes it the perfect choice for functional prototypes and technical applications. OK Compost certification according to EN 13432 high-speed printing, biodegradable and recyclable matte print finish, tooling colors available, AMS compatible. What we need to mention about printing, here we need to be honest with customers. Practical tips.
HT-PLA prints similarly to standard PLA.
But due to its higher stiffness, ensuring strong bed adhesion is essential. First layer, crucial for successful printing. Make sure the nozzle to bed distance is properly calibrated. Filament calibration is strongly recommended. For large models, it is recommended to design sacrificial surfaces to be removed later in order to minimize the risk of deformation. Bed surface and adhesion, because of the material's stiffness,
HT-PLA
has a tendency to slightly warp at the corners. The best results are achieved on a Bamboo Lab cool plate super tack. In many cases, no additional adhesive is needed, only a bed temperature of around 35 degrees Celsius. However, if you are using a PEI build plate or another surface, we recommend applying additional adhesives such as Dimafix, 3-DLAC, or Magagoo. Always clean the bed thoroughly before applying any adhesive to remove dust and grease. Always clean the bed thoroughly before applying any adhesive to remove dust and grease. Warping. With larger models and sharp corners, slight warping may occur. Always use a brim, minimum 5 mm, to improve adhesion and stabilize the first layers. Cooling 80 to 100% depending on the model geometry. On printers with an enclosed chamber, better results can often be achieved with the doors kept slightly open. By following these tips, you can successfully print
HT-PLA parts
that are durable, visually refined, and dimensionally stable up to 150 degrees Celsius without the need for any additional heat treatment. Alright, this video was really fun to make and the filament is absolutely great. And you can see in all the tests that we did, it performed great. So if you want to purchase the filament, the links are in the description down below. As well as some guides how to use the filament, to load the filament, the profile, and all the settings are in the description down below. If you have any questions about the filament or spectrum filaments in general, please do leave a comment down below and make sure you like the video and subscribe if you're not. Thank you so much for watching. My name is Alessio, this is Spectrum Filaments, and I'll see you very soon in the next video.